Now for the next thing in section 5.4 is going to be called special factoring techniques. So we're still doing certain methods with factoring. So for the next thing, we're going to be doing difference of two squares. So this is another factoring technique. Okay, so what this is this is going to be the reverse rule for multiplying the sum and difference of two terms. So before, we were multiplying a times b times a minus b, or a plus b times a minus b. We called those conjugates. Those are conjugates. Same two terms, one's addition, the other subtraction. When we multiplied those, we got a squared minus b squared. So that was a shortcut way of doing it. Now we're going to be doing it the reverse direction. We're going to be starting with something in the form a squared minus b squared, and we're going to know to factor it as a plus b times a minus b. And I put a little note here, this does not work for a squared plus b squared. It has to be the difference of two squares, meaning subtraction. So for example, let's factor x squared minus 4. So factoring this, we're going to recognize that this is a difference of two squares. It's subtraction, so difference. It's x squared. The second term is 4, which is 2 squared. So it's x squared minus 2 squared. So based on this rule right here, it's going to be x plus 2 times x minus 2. So that's actually going to be the factored answer for this one. The a value is x and the b value was 2. So x plus 2 times x minus 2. And then you can factor that or FOIL that back out, distribute, and make sure you get x squared minus 4 if you want. So I'm going to put a little note over here. What if we wrote this as x squared plus 0x minus 4? So this is the same thing, right? We just threw in this x term but put a 0 coefficient, so it's the same thing as x squared minus 4. The reason why I wrote it like this is because we can actually factor this like we used to with factoring a trinomial. It's x plus or minus something times x plus or minus something. Two numbers that multiply to negative 4 that add to 0 would be plus 2 and minus 2. So it's same concept as before, except this way is even shorter. Okay, next one we have x squared minus 25. So this is the same thing as x squared minus 5 squared, because 5 squared is 25. So this is going to be x plus 5 times x minus 5. Okay, so easy as that. Next one, we have 9y squared minus 16. So I'm going to write this like this. 3y all squared minus 4 squared. You can skip these intermediate steps if you can figure it out off the top of your head. So 9y squared is the same thing as 3y in parentheses all squared. So this might make it a little bit easier to recognize how to factor this. It's 3y plus 4 times 3y minus 4. So for this next one, x squared minus 7, since 7 is not a perfect square here, we can say that this is prime, meaning we cannot factor it. Or I'm going to write over here as a little note. What we could do, which this isn't really going to come into play for us, but just kind of keep this in mind. X squared minus 7, you could write this as x plus radical 7 times x minus radical 7. So just keep that in mind. For now, we're just going to be writing the answer as prime, meaning it cannot be factored. Okay, for the next one, we have y to the 4th minus 81. So I'm going to write this as y squared squared minus 9 squared. So if you want to write it like that, just because it's easier to visualize to see what the next terms are going to be in the next expression when you factor it. So y squared to the 2nd is the same as y to the 4th, and 9 squared is the same as 81. So once you have that written out, you can see that it's going to be y squared plus 9 times y squared minus 9. So we're actually not done. We can factor this one more time. We can factor y squared minus 9 as y plus 3 times y minus 3. So we can't factor the y squared plus 9 because that's addition, and we can only do it when it's subtraction. So this one we can actually factor twice because it was originally a degree 4. Okay, we'll do one more of these ones and then do the next one. So 81m to the 4th minus 16. So I'm going to write this as 9m. Oops, let me rewrite this as 9m squared squared minus 4 squared. There we go. So something squared minus something squared. So we know it's going to factor as 9m plus 9m squared. 9m squared plus 4 times 9m squared minus 4. So we can't do anything to this 9m squared plus 4. That factor is completely done. We could factor 9m squared minus 4 though. That's going to factor as 3m plus 2 times 3m minus 2. Okay, so a little bit harder again for that one. It was degree 4, so we should be expecting to have to factor it twice using this method. But that is factoring using the difference of squares method. So for the next thing, for the perfect square trinomial, this is just a shortcut method. It's not something that has to necessarily be memorized. But if we're factoring a trinomial, it's a squared plus 2ab plus b squared. If it's in that form, then it's a perfect square trinomial, which means we could factor it as something squared. In that case, we can factor it as a plus b squared. If that middle term is negative, then we can factor it as a minus b squared. So let's see this example. So I'm not going to do it that way. I'm just going to write it a little bit. I'm going to write it the same way that we did this previously. So it's a trinomial with a degree or a coefficient of 1 on the degree 2 term. So that means if we can factor it, we factor it as x plus or minus something times x plus or minus something. So two numbers that multiply to 25 that add to 10, that's going to be 5 and 5. So instead of writing it like that, I'm going to write it as x plus 5 squared. So what that means is that x squared plus 10x plus 25 is a perfect square trinomial. We were able to write it as a binomial squared. Okay, let's do one more for it. So x squared minus 11x plus 121. So once again, coefficient of 1 on the degree 2 term, which means we can factor it as x plus or minus something times x plus or minus something. So we need two numbers that multiply to 121 that add to negative 11. Actually, that negative 11 term here, that should be negative 22. Okay, so it's going to be x squared minus 22x plus 121. There, that looks a little better. So we need to think of two numbers that multiply to 121 that add to negative 22. So those numbers are going to be negative 11 and negative 11. So it's going to be x minus 11 times x minus 11, which we can write as x minus 11 squared. So that is a perfect square trinomial also. Okay, so that technique is same thing, like I said, same thing that we were doing before. I just wanted to at least mention the term perfect square trinomial. So if you ever have the same thing being multiplied, just write it once with the squared exponent. Okay, so here's a summary for these factoring methods. The first one is the greatest common factor. So once again, always try the greatest common factor first, see if there's a GCF. The next one is grouping. So we can factor with grouping. The next one was second degree trinomial, and that's if you either have if you have a coefficient of 1 on the degree 2 term or not a coefficient of 1. We do it two different ways. And then what we just did today difference of squares, and perfect square trinomials. Okay, so that is actually it for section 5.4.